there are like ups and downs to having like very, very nice package ecosystems, especially if you can publish stuff very easily. The nice thing is
Yeah.
you can publish stuff very easily. The problem is
You
people publish stuff very easily, and
yeah.
then you end up with a bunch of nice stuff, but also,
Yeah,
yeah,
actually the
not so
topic
nice
fits
stuff.
quite well. I was trying to dog food how Kotlin multi-platform publishing works, so that I also get a feeling. That I have written some smaller libraries for fun, but I
Hmm.
never really published that to Maven Central because I just couldn't manage to, like, it was too hard. Like, you need to, like, I remember it, you need to create this tickets on Sonar type. It's a Jira that you need to just file a ticket for, and you claim a namespace. And I read something that you need then to copy something to your public GitHub. It's like really, really strange process. And I now also wanted to go through this process once again and set it up. And
Yeah.
it was quite a journey, despite it this time being actually much simpler, I guess, because for some reason I saw that the namespace io.selma that I wanted to use for my library to publish to was already linked to my account. But on the other hand, like, seemingly the Sonatype, the company that's hosting Maven Central, now has a second, like, they have now a legacy system and a new system. And I read the documentation, like, here's how you publish to Maven Central, and then here's the docs for legacy, and then the new one, and then you can migrate to stuff. So I,
Oh
I, I
boy.
set up my account for the new system, and like, I'm going to do this. Like, I will be publishing my library here. Like, no matter how hard it will be, I need to manage to do it because I need to feel the pain. Otherwise, like, I have no idea what I'm
Of
talking about.
course.
Yeah. And then I go to the website, and I here's like this nice button, like, claim your namespace. And I claimed the namespace. I have this domain, selmar.io. I want to use this for publishing my packages. So I claim this, and I type it in, io.selmar. It's like, you need to do it in like this reverse order. It's not, you own the domain selmar.io, but you need to order it, like, you need to enter it in io.selmar. You need to know this. And it says like,
Okay,
oh,
that makes sense.
this namespace is already claimed, and I have no idea where it was claimed. And then,
Who the hell claims that
yeah, that
namespace? It's
I,
weirdly specific.
yeah, like, nobody. It was me in, like, I don't know, 2018, but it doesn't show up anywhere because I'm using the new system. So I need to try to find out where the old system was, like where the old website is. And then they have this Nexus, which is their tool for managing. Like, you probably remember Artifactory, and then from Sonatype they're offering Nexus as a tool, like as a product from them to manage artifacts. And they have this Nexus instance for Maven Central. So I tried to log in there, and I managed to get logged in, but it's like the interface, I just couldn't see anything there. There
What
was
the
no
hell?
namespace claimed. So of course I needed to go and write an email to the support team, and then they migrated to the new namespace. Then I just needed to walk through a few tutorials, ended up with like some third-party library Gradle plugin that allows for publishing. You need to jump off through a few hoops, and then now I managed to publish the libraries, but it took me probably 4 to 5 hours, I would say.
Okay, 4 to 5 hours. I think that's okay-ish. I mean, I thought you're gonna say like 2, 3, 4 days, but okay, it's. But you also have to keep in mind that you are somewhat experienced in that thing,
And I
so.
already had this namespace claimed, so it seems that I didn't have to do this weird things where I copy some random token to my GitHub profile to make sure that this is actually my
Mhm.
GitHub account. So
But
I had already a shortcut there.
yeah, okay, but I think 4 hours, 5 hours is okay. But of course, it's somewhat annoying because some people might just stop in the way of doing
Yeah,
that and they
pretty
don't
sure.
commit. But now that you have set it up, is it like in some way automated? Like if you, I don't know, push a tag and then just uploads it automatically and does the stuff.
No, of
Is
course
that
not. I publish from my local machine, like. But this part will be rather easy. So I struggled with setting up the signing for Maven Central.
Mhm.
So GPG, I had some, like, it is some weird thing that I never really used, and I feel not too comfortable with it.
Mhm.
And of course, it uses some plugins, so you need to convert some key files into a different format, and all of this is just like you feel like I don't know if I'm doing it correctly, and maybe I'm not sure if I will just mess it up. But in the end, it's for signing. Who cares, anyways, right? So even if somebody would have my public key here, and he can sign those packages, but he still needs my token, right? Which I certainly didn't push to my GitHub repository.
No, of course not. Starts panicking.
No,
rereads history.
But it's like now actually I need to provide this private key on the GitHub runners. So I can set this up, and I will set it up afterwards. Right now, the library is not even open source, so it's a private GitHub repository, and I'm still tinkering around with this, and I'm publishing like alphas and just trying to figure out what
is the library doing?
It's of course it's a state management library. Like of course it's the fundamental way of how I write apps. And here's like my state library and some events, and it's like very simple. It's I think 30 kilobytes. It's a few functions. It's very, very simple. I think it's actually nice, and I like to work with it, and I think it can do a lot. But it's a very simple library. I target all the platforms that we have. But in the end, like the process of publishing it to Maven Central, the only reason why I wanted to actually do this and create a library like this and extract it from one of my hobby projects is actually just to get a feeling for how difficult it is to publish a library.
Yeah, of course. How would you say how much available libraries are there for multi-platform that you can? I mean, for example, for pub, it's usually just very easy. You just go into pub.dev and you just start to write some keywords, and you will end up with some library that you can use. The quality of the library, that's a different story, but there's definitely a lot of options. Haven't looked into multi-platform libraries that much. How big is the ecosystem there?
Yeah,
would you say it's
It's really hard for me to predict, actually, because for my hobby projects, I tend to not use a lot of libraries, like just a few. Like I would say not even 5 libraries. I really like SQLite. Like of course I don't wanna write the raw like handling of like how is it called JDBC. Like I just want something that sets the database up for me. I like with SQLite that I'm still writing the SQL statements myself. I think that's pleasant. But then dealing with cursors and like doing the raw access to databases, that's painful. So of course I use SQLite. I use something that wraps around shared preferences because it's just convenient. But other than that, I really don't use anything fancy. Except if you would of course count all of the Google libraries material or so. But I would say that doesn't count. It's just like it's part of the platform now.
Yeah, I agree. I also think for example, Kotlin multi-platform, you don't need so many packages, because if I, for example, look at I don't know, if I start a project, I also throw in some libraries for shared preferences. Yeah, you did this as well. But for example, also very small things like generating a UUID. I think in the previous episodes, I named this as an example because previously I would just add the dependency for that. And in that case, it was so easy to just write a UID function that I don't even need a dependency, which is kind of cool.
Yeah.
I also, to be honest, don't really know how you would... I'm not sure how you would, for example, write a location plugin, or I would say plugin or a library or a package, because you have so much control over the native platform so easily that I would not find a good enough abstraction to have a nice location plugin. For Flutter, that is, I would say, people come up with a nice abstraction, and if you don't have so much access, it's quite okay. But for Kotlin multi-platform, I always have the feeling that just because I'm able to access native APIs so easily, I don't really want to have a library and then be limited by this. But again, it's just a gut feeling from me. I'm not sure if that's actually the case.
Yeah, it's really interesting because the same solution or the same abstraction now feels weird. Where on Flutter, you're happy that somebody did the work for you.
Mm-hmm.
And you're like, oh yeah, cool. Like this library can do a lot of things for me, and I don't need to do a lot of method channels in this case for myself. And yeah, it's nice and it feels good, but the same library with the same abstraction would suddenly feel not good for multi-platform, because now you just
Yeah,
feel like,
exactly.
oh no, this abstraction limits me. But what if I need access to this really special API that this library doesn't provide me access to? And then you suddenly feel like, oh no, it's limiting. And maybe now it's even pushing some of the KMP library developers to build these huge abstractions that get really complicated, because they also feel like, oh, but what if I am just providing an abstraction that is limiting users? And then you end up with like maybe even a mess, because nobody would need these features. It's all just about what ifs, right? Because like you think, what if my app suddenly scales to 100 million users? Like we like to think about this, but we don't acknowledge that our user base is 100 people, right?
Yeah, that's a very good take. I agree on that, but I also think that there's also more like a gut feeling. I think that most packages, like Flutter packages, are very much straightforward implemented. I mean, at least most of them, they're like very, very easy. Like you want to get a location, there's a future, there you go. You
Yeah.
have that, and it works out quite well, and you don't really have to care about the underlying platform that much. Maybe you have to configure it by adding like a permission to your manifest or your info plist, but that's it. But they usually have a very, very straightforward way of implementing this, which I like. And as soon as I switched to KMP a little bit, I was always, because of course I thought about, hey, should I create a new package or a new module and put the stuff into that? And I already started to structuring a little more complex. And yeah, that's
I think actually the limitations here might actually be good, because it might push to the simple solutions. So of course, like you could say KMP developers should just get the discipline to not do overly complicated things, but you can always make the argument that you should just be more disciplined.
Yeah, I agree. But let's see, to be honest, because for example, for your Bluetooth implementation that you wrote for your project, I guess you also had to find a common API that you use on both platforms. Have you felt like you struggled a little
Yeah, a
bit with
lot. Like
exposing?
it's
Yeah,
so hard. Like it is so hard to actually like when you for Bluetooth is a really nice example for this, because you start by writing some of the UI and you have an idea of what the app should do, and then you get to like, oh hey, I would like to use Bluetooth here, and then like the natural thing to do is you go into in your common main code, the code you share across the platforms, and then you start writing some expects and some interfaces. But the problem is you have no idea yet how the platforms, at least at that point, I did not have any idea how the underlying platform APIs looked like. So I tried to think about like, hey, how would I like to use these interfaces from the application side? And then I tried to implement this with the actual platforms, and it was an entire mess. Like I need to redo it several times. I still don't have a good solution or like a good answer on how this should actually be addressed. But in the end, I thought that really what worked for me was deleting all of the code in common main, just writing code for the platforms, and then seeing afterwards what is a reasonable thing that I could share and a reasonable thing that I could extract. And if I, for example, saw that, oh yeah, I need some common way of identifying a device. Okay, here's a class that can handle IDs, for example, or MAC addresses. So yeah, I can share that. And then you start extracting more and more, and then maybe you end up with something reasonable. For my particular case, I'm not happy at all with the implementation, but I also browsed like through all of the other Bluetooth libraries that I was able to find, and I thought to myself like, yeah, okay, like they do it better, but they're doing it not so much nicer. So it's not that it's so much more readable. And then I just accepted that, yeah, probably Bluetooth is just hard, and it will end up with like strange looking code because you have to do strange things on Android. Mostly you have to do strange things on Android, to be honest.
Yeah, it's not always Android, but sometimes Android.
Most of the time it's Android. For Bluetooth, come on, like
yeah, okay.
in this case, we can blame it a little bit.
Yeah, we can also talk about camera APIs if you want to. Nah, but I feel this. I had the exact same struggle when writing um, a library for Flutter, that I started with this and I thought, oh, it's such a nice idea to have just this single method. And then I quickly found out it doesn't really work. Behaves completely different on iOS and on Android. And I've seen other library maintainers in the Flutter ecosystem um, fixing their problem by just not addressing it at all. Like they just give you a method where you can say, hey, please, like just a simple example, you call a method which is called get Bluetooth manager, and that is just, I'm just making up an example, but you get a sealed class back, and that is an Android Bluetooth implementation or an iOS Bluetooth implementation, and then you just have specific methods that is literally one-to-one the methods that you have on the native side, which I mean in multi-platform doesn't make so much sense, but on Flutter side they do it, and I find this to be way easier. Like it's okay, now you put the work to my side, but at least I know
Yeah.
where the problems are and I can dig into this and I know what happens under the hood, because worst case, you have one interface, and then in order for this interface to work on iOS, you have to do some magic stuff under the hood, and you have to combine certain things. I don't know, request a permission and do this
Yes.
and whatever. And then the responsibilities on my side, but I know what to do.
Absolutely.
Then that's also a little better.
You can write all the code that you would like to write, and you can achieve anything here. I think for multi-platform, it's every multi-platform developer will get excited about this expect actions and like think that, oh yeah, I will be able to do so many powerful abstractions. And then you write this function, you're like, expect function start Bluetooth, and then you're like, yeah, cool, like I can, and then you start implementing the iOS part maybe for the first, and then you're like still happy, like, yeah, I'll be able to do so many cool abstractions, and then you get to the Android part, and then you think to yourself like, I need the context, but the expect function doesn't provide context. I can't even have it in the signature, so you need to do these strange things where you then have like a parameter, and then you reach always into this like sealed class territory where it's in the end something like, yeah, here's your Android context, be happy.
Yeah, that was also funny that the first time I started working with multi-platform, I also had to get the context somewhere. I think it was also in the SQLite. I think when creating the SQL driver, you have to have a context, and I didn't read documentation. I just dropped in the library. I was like, it couldn't be so hard. Start with an expect actual on iOS, pretty straightforward. Don't need anything, just create the driver and call it a day. On Android, you get the context, and I was like, shit, okay, let's maybe read the documentation because I have no idea how to get it. And of course, they had samples and everything, but of course, those are the problems you go around. The interesting part is I haven't done anything beyond the iOS, Android, and macOS world with multi-platform. Do you know how the whole stuff changes with web, for example? Is there also some tricky parts?
Yeah, definitely. Like just for one example, like the JS, like people that use Kotlin with JS, they often have this special source set that they just call concurrent main, because like, okay, here's all the other targets can run stuff concurrently. Only JS doesn't have this concept of thread, so you need to do a lot of special casing. And if you're on any other platform, you can just like do something asynchronous, like not just asynchronous but in parallel. And here's like your JS implementation. It basically doesn't support some of the operations because you can't launch a thread there. And then they have this whole source set. They call it concurrent main most of the time, or they call it everything except JS main. So there are differences.
Crazy. I mean, we have similar problems for Flutter because we cannot just. I think you cannot just run an isolate on or create a new isolate on web. I think that doesn't work. There are ways around that and different things, but can't you just? I'm a total web noob, or like in a native web world, I'm not so experienced. Can you just have a web worker and
but then you need to like use the proper web worker APIs. They are then not available in any other platform, so you need to write that in the JS specific code, and then you need to also be aware that this brings in all the platform specifics, as in like I think I'm also not a web expert here, but I think that when you use these web workers, they are also isolated, so it's basically like a separate process.
Yeah, okay. Yep. That's again for Flutter developers not a big deal, because isolates in our case are always isolated, because I mean they're named isolates. Yeah, but that's also sometimes I really wish for. Not sure if we should open that discussion up, but I really wish for a different threading model in Dart, and it's a very rough discussion, because many people think it just introduces problems, which to some degree is right. Shared memory across different threads.
It's
on
hard.
the other side, it's somewhat so convenient to just be like, alrighty, give me a new thread, do the shit there, and then once you're done, it's so nice. But on the other side, you have to think about a lot of stuff.
Yeah, I love coroutines so much, but I think they are really harmful for a lot of beginners. It's so hard to learn them.
Really? I find them quite easy to learn.
Good for you, mate. Because I still need to practice. Like especially when I start writing tests for coroutines, like my states library is like the states and events library that I was talking about. It is using coroutines a lot, and I obviously want to make sure that I'm handling it correctly. So I start writing tests for it, and then like the amounts of me fiddling around with the tests, just making sure that they pass, because like of course I use a test scheduler and it's like all under this nice test fixtures, and I should be able to just control when stuff happens. But like the amount of times when I just do whilst writing the test, whilst I do like a delay 500 or like repeat 500 times, yield the thread just to make sure like, okay, will this help me out? Like, will this solve my case? Of course, once I figured out what's wrong with the test case, I'll fix it up and write it in the proper way. And then I still realize that I'm still learning here, because now when I write tests, I start with very different ways or styles of writing this test. And now I feel much more comfortable with like controlling and taming this multiple threads or multiple coroutines running at the same time, and then me trying to write a proper test for it. But I'm doing this now for a few years, and I also have my own implementation of coroutines. You know that when I was working at the Kotlin Gradle plugin, we didn't use the Kotlin X coroutines because it does not fit within a Gradle process. It's not the abstraction that you need, not at all. So we have written or like most of the time, in this case, I was writing this library for the Kotlin Gradle plugin, which is a coroutines implementation based upon just the raw compiler feature or like the language feature. And still, I think I'm still learning massively, and I'm still improving, and I'm still not a perfect coroutines developer. So I think there's a steep learning curve.
Yeah, then maybe should dive into coroutines more, because if I haven't had any big issues so far, then
or maybe you're just a different breed of developer. It's maybe it's just a me problem.
I don't know, to be honest. I mean, maybe I just, to be honest, I also had very simple use cases so far. So maybe at some point I will hit this level, and then I will also be frustrated. But I think in the last few years, I spent a lot of time programming asynchronous stuff, but mostly in a Dart context.
Yeah.
And that maybe taught me some stuff. But I think in general, if you have like, I'm not sure if it's also to some degree like parallel, but as soon as you have like a lot of parallel programming, stuff can run synchronously or asynchronously. Then if you even have like something that is like has a time interval in between, that's very specific to some use cases, but it's just a nightmare to test.
Yeah.
And then especially just like a simple, I don't know, maybe you also discovered this while you're testing something in a business logic where you have a timer that emits something at a certain every X second or milliseconds. Just writing tests for this simple use case is already so shitty. Like sometimes you end up with like a few more emits, sometimes a little less.
It makes me so happy that you're suffering here.
Yeah, it's
because like, I think this is one of the cases where Kotlin X coroutines did actually quite well with they have like this. Basically, they have this test fixture. You have a high level or top level method that's called run test. And what this run test will do for you, it already installs a scheduler and dispatchers that are all instructed to run in a test mode. And every delay, like it is completely under virtual time. So every delay you have will just, if you call anywhere a delay of, let's say, delay me for 5 seconds, then it will just bump the internal timer to 5 seconds and it will just like process through it all instantly. But it doesn't actually wait for 5 seconds. And you have all these cool features, like you can go to the current clock or the current timer and say like advance the time by 5 seconds, and it will immediately run everything that is within the next 5 seconds. You can say run everything until you're idle, like there's nothing on the queue again, and then you can write this nice test. So they did this part really well. Where I think Kotlin X coroutines gets too complicated is when it comes to the scopes, because I think Dart doesn't have the concept of coroutine scopes or asynchronous scopes where you make sure that you really do not leak something and do not run something when it's not necessary anymore. And yeah, structured concurrency in Kotlin is great because you can do so many great things, but it's so hard to understand in my opinion.
I mean, let's just go back to the first thing you said, that you have these very nice, I would say, testing framework, because that's exactly what I slowly integrating into the workflow right now. Like daytime now, I hate it. Like in every single test, I have some business logic component that does a daytime now. Again, somewhat specific to a certain app that I'm writing. But then I just, in so many times, I had like this daytime now, just this creation of daytime now. I made that for my test injectable so I can create custom daytimes in order to test this better. Or, for example, I have a timer that emits every X seconds. And instead of like the timer triggering the stuff, I, again, in my test, made just the method be triggerable and not use the timer, because it was easier for me to say, already, now that the timer has triggered the method, I'm doing this manually, and then I'm asserting that certain things happened. That was, so I built most of the stuff by myself, and having this out of the box is just a joy. So
that's really cool. And they do support having even concurrency, and you have different kinds of schedulers. It's again a learning curve, and you need to read the documentations and play around with it. That's probably the most important part when it comes to coroutines. Just reading the documentation will not do the job. You need to write some small snippets of code, run them, and understand by doing, like apply the thing.
But I think that's I think that's a good thing, especially when working with concurrent stuff. Like execute the stuff X times, see how the stuff works, put in a few print statements, get a feeling for where it's executed. That's kind of cool. The second thing you said was about some scoping.
Yeah,
we dive into scopes. That a little bit. Maybe just very briefly, what are coroutine scopes and how would you like create one and use one?
Yeah, so a coroutine, like you cannot just launch a coroutine in Kotlin, right? You cannot just say like, do me something in the background. You need to say like do it, but do it within the scope. And this scope has a certain lifetime. It can get cancelled, and it might have like a hierarchy. You can have within a coroutine scope, you can create new coroutine child scopes. And when the parent dies, it makes sure that nothing as a child is still running, everything is cancelable. And this is great because it means that if you launch something, let's say, let's stay in the context of writing an Android application, and you're UI focused, and you start some activity. User presses, like watches a profile on Instagram. So he goes, clicks on the profile on Instagram, the Instagram profile starts loading, and certain background activities have to be triggered. Like, for example, fetching images or fetching the posts that are on the profile. But as soon as the user presses back or switches to another profile, this activity dies. So it calls first the onPause, and maybe even the onDestroy methods. And then you suddenly do not care about all of those background activities anymore. So they should die, and they should be scoped to the lifetime of this activity as one example. And this is where a coroutine scope would be defined in your main activity, and you would see that there is a life cycle scope. you can launch inside this life cycle scope of the main activity, and everything you do then in the background will be scoped to the coroutine scope of your activity. And when it's just this case, it's simple because you get the coroutine scope for free. But when it gets more complicated, let's say you again do Bluetooth, you have devices that connect to each other and you need to manage their scopes, then suddenly things get much harder because you cannot just create a scope easily. Like you can, and actually people might argue that it's easy, but the problem I have is with the learning curve that you have, because it's one thing more that you need to understand, one concept more, instead of just marking a function as async, calling it, awaiting the future. You need to also have some coroutine scope. And God forbid, if you're in a suspend function, you want to launch a new coroutine, you also need to get access to some kind of coroutine scope. So how should you pass it down? Should this be the receiver of your function? Then the IDE complains and it gives you some weird hints because, now maybe the access to your coroutine context is ambiguous. And all of this can be really confusing if you're a beginner, or maybe even a really good engineer. You wrote a lot of code and then you suddenly start working with coroutines, and then you see IDE warnings that you're not familiar with, and you wonder what's the best practice. And if you learn the best practices, you will get a good tool for making sure that your coroutines do not do something that is unnecessary anymore. But it's like one more thing to learn.
Of course, I think in the beginning it might be annoying, or let's just call it might be annoying. But I think, again, looking at this from my Dart Flutter, through my Dart Flutter glasses, it's something that I wish for in Dart quite often.
Really? Like, that's interesting.
Like, for example, I have the biggest problem. Let's say simple example. I have like an asynchronous function in my UI, in my widget, or in my view model, and there's a feature, and that feature runs, like the user presses submit, and then maybe I left the screen, so my view model is disposed, but the scope, I don't have a scope. Like my future can still continue, and then your method call or your API call is done, and then the view model is already disposed, but then you maybe try to update the state. You'd be like, alrighty, now here is the result, now put it into the state, and then there's an exception thrown.
Yeah.
So many times in my code, I just have like this super annoying code where I check, is that view model disposed? If yes, then just return. And that just is super annoying. And also when I do code reviews, I always feel it's so dumb, but it's just annoying because it doesn't crash your application entirely. But again, it's just it's an exception that is thrown that you see in your crash reporting tools, and that is totally fine. And on the other side, we also had different things where, again, somewhat specific to an app that I was writing, we had like a lot of asynchronous operation that can they can run concurrently.
They can love concurrently.
And the problem is, if you, for example, if one of this operation then, let's say, cancels a process and the other one shouldn't continue running when the process is canceled, then you also have to check for that stupid thing. And in that case, you can just cancel the scope, and then you don't have to care about it.
Yes, exactly. Like
that's super nice. And this is what I would love to have in Dart. I just don't have an idea how to make that work, at least not right now with the current language features. Yeah, but again, of course, you have to think about it. But it would be nice if you can write this normal async await or suspend code without worrying so much. But then if you need control, you can introduce it. Maybe this would be some kind of a
maybe something optional. In Kotlin, we had this global scope, and you could do global scope.launch, but of course, it was quickly established as an anti-pattern. You shouldn't do this. And people, I think there's like, people are just too afraid of using something like this, even if it would fit their use case. I give you one example, which is in the states library that I'm currently doing, I had this. I'm actually using something that doesn't have a a good coroutine scope, it's basically using something, not the global scope, because I have a very dedicated use case, but I'm creating a coroutine scope out of thin air, and it is certainly not canceled at all. And it's like I think I know what I'm doing, and I actually also I mean I have access to the experts that wrote coroutines, so I obviously just asked them as well if this is okay. But turns out like I was benchmarking my event bus, and previously it had a throughput of just I think 2,000 or 3,000 events a second, which sounds bad, but it's an asynchronous event bus. It even waits like every time you emit, it will suspend until all the receivers got the message. So 2,000 events it's not a great number, but it's also not that bad considering what it's doing. But then I wanted to optimize it, and I ran the benchmark. So we have got the next benchmark, which is a really cool tool for doing this. And with just this little coroutine scope that I had, I managed to bump it up to 1.5 million events a second. So huge.
But are you waiting? But are you waiting for a response of every consumer?
Yes, you could, but the idea is that you don't care.
Okay.
So you like exactly this, like the dispatch and waiting for the dispatch to finish. I thought that nobody cares. Like you want to like at this point you want to send the message, and if the receivers do not even want that it gets dispatched, because let's look at it like this. It is designed to write UI applications, so maybe the event comes from the UI. It should be picked up by something in the back end of your application, like a view model, for example. It should maybe just quickly process this event without dispatching it once more on the main loop. Just like trigger the operation, and then it should just be updating the state immediately, so you don't get anything flickering on the UI. So there shouldn't be any kind of like waiting or dispatching between threads. I created this like coroutine scope that does a buffer without actually requiring a scope, because it's just like whoever calls into this buffering method, you just enter it, no dispatch needed, and basically does something on a global scope. Then it doesn't have a job. It's not scoped properly, but it works. And I think even despite me not being so afraid of doing something really stupid, because I don't know, like I always thought that in the end you can fix it. But I also had to ask the inventors, the maintainers of Kotlin coroutines, to check like, hey, is this somewhat legal? Is this somewhat okay what I'm doing here?
But I mean, so not sure if I understood that perfectly. If you create just a scope out of thin air, when does it just live forever? Does it somewhat, I don't know, does it leak memory? How does it work? Is it just deallocated if it's done? Like, I'm not sure how that works.
Yeah, see, I think that's exactly my point but my criticism with coroutine scopes, because it's so hard to understand what all of it is actually doing under the hood. And if you think about it, all of the coroutines are a stylish way of writing like listeners that you register somewhere and unregister somewhere. And yes, in the end, at some point, I do not unregister. Like when I don't have this coroutine scope, nobody will ever unregister this listener. But that's fine, because I have this class. It has methods that are private, and there are just some listeners registered in this class that only this class knows about, that never call an unregister function. Yeah, but it's okay, because it's this class. If nobody needs this object of this class anymore, then all of those listeners will just be discarded anyways. Nobody would have a problem if you wire something up internally and you have a way of registering a listener, and then you do not have an unregister method because it's all internal to this one object. Then nobody would care. So no reason for providing a scope that calls an unregister function.
Interesting. Because I would also be afraid of doing something like this, because I don't know, for me, it's also, whenever I do something asynchronously, I'm more afraid of leaking memory than doing something synchronously. And whenever I do anything with coroutines, or not just coroutine specific in any language, and do something asynchronously, I always think twice about if that potentially leaks memory. Another example where I just wasn't sure if that caused problems, and I'm still not sure, is in Dart, I was creating a future that never completes. in just one very specific case, I was like, alrighty, the whoever calls this method, they should not get anything back. They are disposed anyways.
Yeah,
I don't
they should
care.
just
I'm just
die.
gonna, yeah. And then I was like, I'm just gonna create a future that doesn't complete. Should work, right? That should leak anything. And I was like, thinking twice, and I couldn't wrap my head around how the hell does it work. Still don't know to this point. I have to do some experiments, but this is like,
yeah, exactly.
And I got this comment in a code review, and I was looking and staring at that comment, trying to figure out how the references are somewhat connected, and I couldn't figure it out.
Yeah, because
then I was like, alrighty, let's just remove it. I don't care. In that case, it was not super important, but again, still, this is somewhere in the back of my brain, and still doesn't let me sleep at night.
Yeah, been there, done that. I also created a function that was called never, a suspend function that just never returns. So everybody who calls into this will just die. Its return type was nothing. The implementation was runs or suspend coroutine, and the continuation object that was get passed into it was just never called completed. Finished. Yeah, never called finish. So it just dies. And I think that's exactly what this async await style of programming does. It hides away where you actually put where you actually register a listener, because that's all it's doing. Like at some point, there's a listener, like this in Kotlin's case, continuation object where you can, or future, where you can call complete, where you can call complete exceptional. And somewhere you could write all of this code as just a listener registered to something that then gets called back. Like you have this handle of complete this now. But you have no idea where these objects are, because in coroutine's case, they are generated by the compiler directly for you. So you don't need to look at them. You don't need to know where their stuff is happening. And you need to build some kind of mental model that understands when you're in danger land and when you're not. And I think actually like what helped me the most is just writing this bare bones implementation without Kotlin X, and just using what the language features already have to understand that, it's just listeners. I can build everything here just by registering this listener and then completing something at some point.
Oh, that's very cool. I mean, in Dart, we have similar things. We also just have like literally a class called completer, and you can do a lot of stuff just with that. And I really love to, like when I explain people how futures work, I usually like to have an example with, now we have something that has a callback, and now we're going to convert it into a future. And then we usually start from that and then build on top of this. And then we go like, alrighty, now our callback has a result, like gets an optional result, an optional error. And now then we go on with how does it work if we throw an error? Because that's also interesting. Because people, at least in like beginners in Dart, they usually, like error handling apparently gets so much trickier if you are asynchronous. At least some people struggle with this. Like you call a future, and then you invoke the method, and the future is created. And then I always ask people, alrighty, what happens now? You have an API call, you call that method, but you don't await the future. And then you put a try catch around it. And then where's the error thrown, and how do you catch it? Or what happens if you don't await it? And then some people are like, alrighty, then it's not executed, and it is executed, but you just like,
you just never care about it. You'd never care about the results. That's, I think, the main argument why Kotlin didn't use the await keyword, because it's basically error prone to just forget calling await.
I agree, and I have to say I really like the Kotlin way of handling asynchronous stuff. Like we are in a suspend context and everything there. If it's suspended, it's working. If not, you get a compile time error. That's way cooler. In Dart, I have just a linter error that tells me, there's a warning, but you don't have to worry with this. I mean, you can ignore that, but you can do the same with coroutines as well. But by default, it will complain, and like with compiler issue, another lint warning. So that's kind of cool.
Yeah, and I think, on the other hand, I think it's also not too hard. Like you will at some point just know that you have to call the await, or is it really so? Maybe I'm just wrong here. Is it really hard to see all the places where you would need to call await? Maybe now that I'm talking about it, I can imagine that it's easy to actually forget calling await because maybe you have not written the function you're calling into it. There's something like make HTTP request. Okay, that indicates that something is asynchronous, but you just don't look at the return type. You don't see it's a future. You just code the stuff, and then suddenly you're surprised because stuff now works asynchronously where you would have expected it to execute sequentially your instructions.
I had this case many times. I mean, I've been looking through it but quite a few code bases in the past. And something that I've seen, especially with people moving from languages that don't have this async await to Dart, is that they forget it sometimes. Even if you don't have like a very good linter that complains about these things, you just sometimes forget it. And then I found myself debugging very simple things like you do an insert, and then after that you retrieve the data from the database again, and then in most cases it works, then out of nowhere it doesn't work, and you'll be like, what the hell?
Yeah.
And those race conditions are super stupid to find. And also sometimes you just refactor a method, like already now it has to be asynchronous. You change the return type to future, but you have like 6 places where you call this function, and now you don't know, and then apparently it is important.
Oh, that's a really good one. Like, this is a really good example where things like I just convinced myself that the linter is good enough because I thought like, oh, wow, we're grown-ups. Yeah, of course, you can do mistakes, but the idea is marking your code as yellow. How hard can it be to just listen to it and just put a dot await or await in the front? But you're right. Like, what happens if I refactor a function? Then you're in danger land because everything might compile, but if you do not check every call site, if it's now handling it correctly, then you're in danger.
Yeah, and that's why it's kind of cool that you then have to care about this.
That's true, yeah.
And then again, on the other side, in the same refactoring, if you then have something that waits very long, having some kind of a scope to think about, do you even have to care about the result? Yeah, let's see. I am still very much looking forward to static meta programming in Dart being stable.
Mm-hmm.
Maybe we can play around and have some kind of a coroutine scope-ish API. That would be nice.
Yeah, that's a good next topic then.
Oh yes, that's actually a nice idea. That's cool. Yeah, we can also do static meta programming in general.
Yeah, let's do this.
Also
because there's so much stuff going on.
I have so many strong opinions on that in Java.
Really good.
Yeah, I also have some pain there, but I think that's a good stuff for the next episode. Let's not forget that.
See you next time. Bye bye.
Yeah, see you. Bye bye.